So this question is about organic compound X. Information about X is C4H10O, so it looks similar to that we did in the last part. And is for a spent chloride was added, it gave a steamy fume, so this confirmed that it is alcohol. So use the information about X, identify the type of functional group present in X. So we can say it contains hydroxy group, or we can also say OH group is present or OH group might be present. So here it might contain hydroxy or OH group. Then draw 4 possible structures of isomers and use your answer to A1. So possible isomer of X is it was added to X, so X is alcohol. So and it contained 4 carbon atoms. So what could be or what might be 4 different structures we can draw for this? Number 1, it can be a primary alcohol, it can be a secondary alcohol, it might be a tertiary alcohol, or it might be a branched alcohol. So if I and structural formula, so it might be CH3, CH2, CH2, and CH2OH. This is one possible, like C4H10O. The second possibility that OH might be attached with a second carbon, that makes it secondary alcohol because the carbon which is attached with OH, and it might be a tertiary alcohol, the carbon which is attached with OH having 3 carbon chains. So primary, secondary, and tertiary, these are the alcohols. And what else? It might be a branched primary alcohol. So these are the possible structure. These are the possible structures of this C4H10NO, possible isomers. So might be primary, might be secondary, might be tertiary, or it is a combination of primary and the branch one. Then the next part, another test was carried out on X. A few drops of acidified potassium dichromate was added. The mixture was heated. When we add potassium dichromate to alcohol, it will be oxidized because it's oxidizing agent, but mixture stayed orange. So it means this confirmed that it is a tertiary alcohol. So use the result of test to further classify the functional group present in X. So what will be the classification? Further classification, basically it is a tertiary alcohol. Use your answer to B to identify which of the 4 isomers could be there in, so which of the isomers, so it should be tertiary. It means that carbon which is bonded with OH surrounded by 3 carbon. So because tertiary alcohol cannot be oxidized. So it is CH3, CH3 and CH3. Write equation for reaction between X and PCl5 and state symbols are not required. So when we have alcohol, like we have C4H9OH, we add PCl5, phosphorus pentachloride. So as a result, it will give POCl3 plus C4H halogen alkane will be produced plus HCl. As a result, it will give a misty fumes. So this HCl is responsible for misty fumes. And it react with all type of alcohol. PCl5 is actually a test for OH. irrespective of what type of alcohol, it might be primary, secondary, or tertiary, but all will give a positive result. So percentage transmittance are shown. The infrared spectrum of X is there. The compound X infrared spectrum is shown here. We don't have to take a 1500 region, but that's a fingerprint region. We have to check what is afterwards. So what is afterwards? There are two peaks. One is this one, the other one is a sharp peak at 2900. And one of the peak is like from 3300 to 3600, which is a broad peak. Some data of infrared spectrum are given. Alkane CH is stretching is given, bending is given, and circle the peak on the spectrum that would not be present in infrared spectrum of organic product. So the organic product is halogen alkane C4H9 Cl. So which of the peak won't be there in C4H9 Cl? Because this this is a OH peak. So this peak is due to what? This is due to OH, presence of OH. But the organic product which is formed here after reaction with PCl5, so that was C4H9 and Cl. It does not contain OH. So which peak will be missing? This peak will be missing because it does not contain OH, it contains Cl. So we just have to circle this peak which is there for OH. Is it clear, this question? A gaseous hydrocarbon X reacted with the bromine to give a colorless product. At room temperature and pressure, 6 grams of X occupied 5.15 dm cube. Under these conditions, 1 mole of a gas occupied 24 dm cube. Show how all these pieces of information are used to identify X and give its displayed formula. So X, first hydrocarbon is there. It reacted with bromine to give a colorless product. So it gives an idea. It acts as alkene because bromine, it decolorizes the bromine. It confirms the idea that the compound X is a bromine because with bromine it undergo addition reaction. Then at room temperature and pressure, when we have 6 gram of that X occupies a volume of 5.14 dm cube. And so first using this we will find the moles. How to get the moles? Moles equal mass in gram divided by molar mass. So we have the formula moles equal volume divided by 24. So volume occupied is 5.14 divided by 24. So this will give us a total number of moles 0.214. And then we have the formula moles equal mass in gram divided by molar mass. So moles are 0.214. Molar mass is, we don't know, and mass in gram is how much? That was given in the question 6. So molar mass will be 6 divided by 0.214. So 6 divided by 0.214, that is equals to 28.5, which is about 29. So we have to check which alkene is having a or this is about like we have to round like 28.57 or 28. Why I took 28? Why not 29? Because when we check ethene, because we want to confirm that which alkene is this. So when we check ethene, carbon is 12 multiplied by 2, so that is 24 plus 4 hydrogen, so that is 28. So this confirm that this of mass is like it matches or close to ethene. So this compound X is ethene. Is it clear, this part? That using the volume we got the moles, and using the moles we got the molar mass, and that molar mass is actually matches with ethene. That's why we say this compound is ethene. And why specifically we know it's ethene? Because in the first line they mentioned this hydrocarbon, a gaseous hydrocarbon, gives a colorless product. So whenever you have a gaseous hydrocarbon, it gives a colorless product with bromine. It means it undergo addition reaction. So with a bromine, addition reaction result in a formation of 1,2-dibromo alkane. Then a compound Y is prepared by reacting X with potassium manganate and 7. So if we have alkene will undergo uh, this oxidation reaction in which it will form a diol. Then Y is a liquid at room temperature. PCl5 was added to Y. It will give a hydrogen chloride. Describe a chemical test for hydrogen chloride other than using indicator. So what is a chemical test for hydrogen chloride, hydrogen bromide? We can use ammonia. Ammonia solution can be used. And when ammonia solution is there, result will be dense smoke. It was found that 0.25 moles of Y produces 0.5 moles of hydrogen chloride when it reacts with PCl5. State what can be deduced about the molecule of Y. So first, look, first we were having alkene C4H9, C2H4 was there, alkene. We added in the potassium manganate 7, so it will produce diol. As a result, diol is produced. And this diol, we added PCl5, phosphorus pentchloride. So the two OH groups are being replaced by the chloride. So 0.25 moles of Y is producing 0.5 moles. So what this gives an idea or what this confirms? So basically, because if it was having, when it reacted, like it will result in a formation of two molecules of HCl or 2 moles. So it means if 1 mole of OH is there, if 1 OH is there, it will produce 1 mole of HCl. But 2 moles of OH groups are there. That's why 2 moles of HCl are produced. That's the ratio between the HCl and this compound Y, because this is compound Y and the hydrogen chloride. So the ratio is 0.25 to 0.5. So it means 1 is to 2. Like one molecule produce 2 HCl. So it means this compound contains OH group. So what we can deduce about Y? So we can say Y is a diol. If it was having only one OH group, then 1 mole of that compound Y should produce, like a 0.25 moles should produce 0.25 moles of hydrogen. Then mass spectrum of a Y. So the mass spectrum of a Y is shown here. Use the mass spectrum to find the relative molecular mass. How to find a relative molecular mass? So the one which is having the, and use your information of relative molecular mass, deduce the structure. So relative molecular mass is the one, the highest peak of the mass to charge, not the height. The highest value of a mass to charge, that's called relative molecular mass. So it is 61 and 62 is the relative molecular mass of this compound. And what we can deduce about the structure, I already mentioned it is a diol. And remember, whenever potassium manganate 7 is added to alkene, that will result in a formation of diol. So when we find the total molecular mass of this compound, it will come out as 62. So this confirms that diol is present. When compound Y was heated, acidified potassium dichromate under appropriate condition, it oxidized to carboxylic. So if it is a diol, it will produce dicarboxylic. Draw a label diagram normally used to make carboxylic acid from alcohol. So what we have to do, we have to draw a reflux condenser. So we have to draw a reflux condenser where in and out is there for the water and open at the top so that it will make a complete oxidation of alcohol to carboxylic and dicarboxylic acid will be produced. Then when compound Y is oxidized, dif- uh, when compound Y is oxidized more gently than B, different products are obtained. Like Z contain only one type of functional group. The table shows the IR spectrum. So when gently we oxidize, it will undergo a partial oxidation, and partial oxidation result in aldehyde. If it was a complete oxidation, it will be, so we have to complete incomplete infrared spectrum is there. Draw two peaks from 4000 to 1500. We have to complete. So Z is basically aldehyde. So if it's an aldehyde, we will have a peak at what region? 1740 to 1720. There should be one peak. And CH 2900 to 2080. There's another peak. So 1740 to 1720, there will be peak. And strong means like intensity strong means like it should be down. Intensity weak means it should be up. So one peak we have to draw from 1740 to 1720. So this is 15, 16, 17. So this is 1700, this is 1800, so 70. So one peak I should have here, and that is a strong peak. So strong peak means that more absorption, that is one. And then the other peak is like 2900 or 800, but that is a weak absorption. So if it is a weak absorption, so how to represent a weak absorption? So weak absorption, so one which is absorbed more will have a greater depth, like strong absorption, greater depth, weak absorption, smaller depth. So this is how we complete the this IR spectrum of this aldehyde. Is it clear, this question?